Today I am testing a flat earther and seeing if he can debunk Chat GPT's 10 biggest arguments against the flat earth theory.
Photographic evidence from space. One of the most straightforward arguments is the overwhelming photographic evidence from space. Astronauts have taken countless pictures of Earth from space, all showing a round planet. These images are not only from NASA but from various space agencies around the world, including ESA, Roscosmos, and private companies like SpaceX. The consistency of these images from different sources and different angles strongly supports the spherical shape of the Earth.
One picture, everything's computer generated. Not one Polaroid, nothing. Show me an actual picture. It always says image if you look in the fine print.
Two, the horizon curvature. On a flat Earth, the horizon would appear completely flat and rise to eye level no matter how high you go. However, in reality, as you ascend, e.g., in a plane, the horizon curves downward. The curvature of the Earth becomes especially evident when looking at large bodies of water or from high altitudes, where you can see the curvature with the naked eye.
What was last time? Apparently AI has never been on a plane, but I fly twice a week. I don't know if you don't have bubble windows, like fisheye windows, yeah. Otherwise, it looks pretty flat with a little bit of an upturned edge.
3. The Earth's shadow on the moon. During a lunar eclipse, the Earth casts a shadow on the moon. This shadow is always round, which is only possible if the Earth is spherical. A flat Earth would cast a different shaped shadow depending on its orientation to the sun, but instead the shadow remains consistently round, as observed during every lunar eclipse.
Get a bowl and a flashlight and see what the shadow is. What difference does the lights in the ceiling don't have anything to do with the shape of the floor? One more to add to that. Why is moonlight colder than sunlight? It's the exact opposite. If it was reflecting sunlight, it should be warm. With your laser thermometer, go out and shoot the temperature in the moonlight and then shoot it in the shadow. It's the exact opposite.
Gravity is the force that pulls objects toward the center of mass, and it is what makes objects fall to the ground. A flat Earth would not produce the same gravitational effects we observe. If the Earth were flat, gravity would pull objects toward the center of the disk, which would create noticeable distortions in how gravity works, especially for people or objects located at the edges of the flat Earth. This is not observed. Gravity pulls objects straight down towards the Earth's center, consistent with a spherical planet.
Okay, so are we talking about Newtonian gravity or Einstein's? And that was all shot in the ass too, but I believe in buoyancy and density. If you drop a feather, a rock, and a tennis ball or ping pong ball off a bridge, the rock's going to go to the bottom, the ping pong ball's going to float, and it'll take a lot longer for the feather to get there. Just like if Randy and I jumped off the same building, who's going to hit the ground first? The one that's a little more dense. The two true actual things that you can measure are electricity and magnetism. Those are the two forces and then everything else is sorted out by buoyancy and density.
5. The flight paths and time zones airplanes follow flight paths that are based on the Earth being spherical. On a flat Earth, the distances between cities and countries would be vastly different from what is experienced in reality. Flight times, as well as the need for navigation based on great circles, the shortest path between 2 points on a sphere, align with a spherical Earth. The fact that flights between different locations, like from Australia to the US, are faster than predicted on a flat Earth model supports the idea of a globe.
What about all the emergency landings that land in the northern hemisphere that never go to the south? And for instance, my aunt just came up from Australia, and it was, I think, like a 23-hour flight to get there. They made it home in 15 or 16. There's 300-400 mile an hour winds once you get up there. And they can shave a lot of time. I made it from San Diego back to Minneapolis in like 2.5 hours one time. That should be a 4-hour flight. But if you got the right tailwind, you can make up some ground in a hurry. But that whole flight thing is, how come they never go over across the top of Antarctica and come out the other side? You don't ever see it in the south. If you look in the southern plates, that's a whole other can of worms. I haven't looked at that in a long time, but if you start digging in that one, bring bread and water, but you're going down the rabbit hole.
6. The Coriolis effect. The Coriolis effect explains how the rotation of the Earth causes moving air and water masses to curve. This effect is responsible for the rotation of hurricanes and the direction of ocean currents. On a flat Earth, there would be no consistent Coriolis effect, as it relies on the Earth's rotation, which can only occur in a spherical system. The observable patterns in weather and ocean currents strongly support a rotating spherical Earth.
Bullshit again, but it's all magnetism and electricity. Well, how do the tides work then? Why do you have 20 foot of tide one place, and you by rights when you get closer to somewhere else, you should have more, and it's almost non-existent. But I haven't looked into that one in a while, but I'd have to get back to you on that, I guess.
7. Observations from different latitudes. The position of the sun and stars changes depending on where you are on Earth. For example, the North Star, Polaris, appears higher in the sky as you move northward, and it becomes invisible as you travel south of the equator. Similarly, during the summer solstice, the sun reaches a different position in the sky depending on your latitude. This would be impossible to explain on a flat Earth model.
Impossible, huh? Again, we're talking about the lights in the sky, and that's got what to do with the shape of the floor, but you can only see so far through the deck of opacity. I mean, the air gets thicker as you can only see so far anyway. I guess not following that one logically, but then there's no, if you go out every night, go out tonight, sit down under your favorite big tree in the yard, grab a beer, and look at where all the stars are in the sky, and then come back exactly 1 year later, they'll all be in the same spot again, but we're moving 4 billion miles a year, whatever it is, and spinning and all this other crap too, so you never see parallax. I don't get that one, but okay.
8. Satellite and GPS technology. Modern technology such as GPS systems, satellite communication, and weather satellites all rely on a spherical Earth. These technologies work by using satellites that orbit Earth and send signals to receivers on the ground. The way these systems are designed and function is based on the Earth being round, and they provide highly accurate data that would not be possible with a flat Earth model.
GPR was actually invented, I think, back in the 60s, and they didn't put a 3D overlay on Google Earth until, I don't think it was less than 20 years ago. Probably less than 10.
10. The way ships disappear over the horizon. As a ship moves away from shore, it appears to sink below the horizon, starting with the hull and eventually disappearing from view entirely. This occurs because the Earth is curved. On a flat Earth, the ship would simply get smaller, but would not disappear in the way it does over a curved horizon. The phenomenon of ships disappearing from the bottom up as they move further away from the observer is direct evidence of Earth's curvature.
So according to their math, it's 8 inches per mile squared. So at 3 miles, you have 6 feet of curvature. Go get a really good camera, like a P900 or one of those really good Nikon cameras, or a really good piece of glass optics, and zoom in and watch what happens. It comes right back in. It's all perspective again.
Well, you gave me this one argument about space and the phone calls dropping one.
All of that, I mean, you can blow that up in a matter of 2 minutes. I mean, that looks like a beer can wrapped in tinfoil, and that's what they went there with 50 years ago, and they don't know how to get back there today.
And the phone calls to space, you suspect that was funny?
Oh yeah, that one. Oh, that would have been Nixon in the White House calling to say congratulations on going to the moon again.
Yeah.
Yeah, that one. Yeah, you can still find that clip on YouTube, I think.
Because we have phone signal service problems today, so your point was
right. You called with no delay, 238,000 miles away. That's funny. I can't drive across the swamp and call concrete, so